Okay, so I'm going to show you something called, for those who don't know it yet, the chain rule. What is the chain rule?
dy over du times du of dx.
That's right. So dy dx equals dy du times du dx. First thing. Alright? I know those who said you've done it, just be patient and just let me get through it with the others, please. So, first of all, when do I use the chain? This is a chain rule. It's saying dy dx, which is the gradient, is a product of dy times du, which is still a derivative. And the thing you have to understand, and people don't get, when you talk about derivatives, the top letter is the name of the equation, the bottom letter is the letter you're playing with. So when I do dy dx, I'm saying the change in y compared to the change in x. Because what is dy dx? Gradient. What is gradient? Rise over run. What is rise? Change in y. What is run? Change in x. It all connects. And you need to be comfortable with that language, because they can throw anything at you. Do you really understand calculus, or are you just a robot and follow procedures that a teacher taught you? You've got to be both. You've got to follow my procedures, but you've got to know basically what it's about. So when I say dy du, you're talking about the change in y compared to the change in another variable called u. Okay? And when you do du dx, you talk about the change in u compared to the change in x. So, just on the sideline, if I said to you z equals p squared plus 3p, and I asked you to find dz dp, your p is effectively like your x. Yeah? So you just do the derivative. 2p plus 3. So I don't care what they tell you, the letter on the bottom is the one that you play with. Does that make sense? Right? And if there's another letter there, it's crap. It's like a constant. Or product. So, this is saying, I've got two functions. This is like composite functions. Right? Remember when we talked about composite functions and you put fog and goff together? I kept talking about doing two jobs. There's two jobs here. Little x, you times by 3 and took away 5. That's job number 1. Bang, you got an answer. And then once you got that answer, you did job number 2, which is squaring it. Right? Two jobs. That's chain. Whenever you look at a function and think, hang on, two things are happening to my x, two sort of separate jobs, I can use chain. Right? Simple way. Anything that's got a power, you're going to use chain. Anything that's got a fractional power, anything that's on the bottom, you're going to use chain rule more than you use any other rule this year. When we get into trig and logs and exponentials and everything else, we're going to be doing chain rule every single minute. Formally. But then I'll show you that we don't do it. We just go a slack way. However, the technique. Y equals. Alright? Using chain rule. Hey.
Let's grab Tom.
Alright? Yeah. When you're doing this, I said to you there's two jobs. dy. The u stands for the inside job. Okay? I call u the inside. So the first thing you do is go let u equal the inside. That's my first simple job. I times it by 3 and I took away 5. 3x minus 5. As soon as I let u equal, my next line is du dx. You let someone equal u, you then find the derivative. So the derivative of 3x minus 5 in terms of x is 3. Yeah? And guys who haven't done it before, you need to yell as soon as it doesn't make sense. You really do. Why? Yeah? Okay, so you've got your function, and it's a composite function. What I want to do, I'm showing it on a simple example, and you'll see more complicated in a moment. But I want to find a new way of deriving without needing to expand things. Okay? So, as like a fog, Goff composite function type thing, this would be like two functions. I would have had an original function, let's say it was f, 3x minus 5, and then I had another function g, which was x squared. Yeah? This is what we would have done in chapter 1 and chapter 2. And then I said, do Goff for me. So Goff is, take f, stick it in g. Yeah? Okay, so you've got a fog or Goff function, and what you want to do is derive it. So I'm going to split back and derive the two separate things, and then put them together according to the chain. So my du dx is like the f, or whoever's after the off, the Goff or the fog, yeah? So the f bit in this case was 3x minus 5. So I did it. They say, hey, I'm doing calculus, so let's practice my calculus. What's the derivative of that? 3. Done. Then I'm doing the g bit, the outside function. What was the outside function? It was somebody squared. So y equals u squared, because I called this thing u. Yeah? So y equals u squared. The chain rule tells me to do dy du. That means pretend you're doing calculus and you're looking at this only. What's the derivative of that? 2u. Yeah? So I've done my g bit, which I've derived. I've done my f bit, which I've derived. And I stick them back together, and I'm deriving fog or Goff or whatever it is. So dy dx is dy du 2u times du dx, which is 3. Answer, 6u. But what the hell is u? You're giving me dy dx and you're throwing this random letter in u. You can't do that. You go back to where u was, and you fill in the gap. So I called it a new letter so that I could derive it, and then when I finished, I put that letter back. There's my answer. There's your answer. But look at this. 6 is a common factor, yeah? Take out 6. Your answer, my answer, same story.